In this video, we're going to introduce logarithmic equations and talk about a couple of methods in our toolbox for solving logarithmic equations. A logarithmic equation is an equation in which the variable occurs in a logarithm. And when solving logarithmic equations, our goal is to use whatever properties we've learned to be able to move the variable from the inside of the logarithm to somewhere else in the equation so that we can get x isolated. Just like in solving exponential equations, we're going to have a variety of tools, and sometimes the tools are going to work and sometimes they aren't going to work, and sometimes we have to use some of them in combination. But right now, we're just going to work on identifying what the tools are, and then we will work on learning how to figure out when to use the tools and how to use them in more complicated examples. Okay. So the first tool I'm calling L1 for our first tool for solving logarithmic equations. It's convert a logarithmic equation to an exponential equation. Let's look at a couple of examples. In this first one, I have log base 3 of 2x equals 4. And I could write this as an exponential equation by converting form and write this as 3 to the 4 equals 2x. Okay, I'm going to take a second and say, okay, what is 3 to the 4? I know that 3 squared is 9. So 3 to the 4th, I think, is 81. And then if I divide both sides by 2, I'll get x by itself. I'll say x equals 81 over 2. Another example here, we have log with no base written there of 4x plus 20 equals 2. Remember that when there's no base there, that means log base 10. So this is equivalent to 10 to the 2 is equal to 4x plus 20. And now this is just a linear equation. I turn this into a linear equation that we can solve. I just say, well, this is 100 equals 4x plus 20. I'll subtract 20 from both sides and I'll get 80 equals 4x. And then we'll divide by 4 and get that x equals 20. Right? I've turned my logarithmic equation to x in a linear equation that can easily be solved. So that's L1. Our next method is to raise both sides, or raise any number to both sides of the equation, which is kind of a mouthful to say, but I'll show you what I mean by that. So in this first example, again, where I'm using that same equation, I have a log base 3. So I'm going to choose to write my equation like this. Because log base 3 of 2x is equal to 4, it is true that 3 to the log base 3 of 2x is equal 3 to the 4. So I can put my exponents, or my two sides of the equations, as exponents with the same base. Having done that, now I have 3 to the log base 3 of 2x, and it's a really good choice to have chosen 3, because now I can use that inverse property and say 3 to the log base 3 of 2x. Those are going to undo each other, and I'm left with just my argument that 2x is equal to 81, 3 to the 4th there. And then we'll divide by that 2 again. We'll know that x equals 81 over 2 and get that same exact answer. If we look at this other example with our log, I want to put the two sides of my equation as exponents on the number 10, because that's the base of my log here. So I'm going to say that 10 to the log of 4x plus 20 is equals 10 to the 2. We'll get 100 on my right-hand side. And on my left-hand side, 10 to the log base 10 undoes each other. Those are inverse operations. So we'll be left with that 4x plus 20, which gets me that same equation that I had up here. And I'll do the same tricks to solve that linear equation and end up with x equals 2.
Oh, 20. X should be 20 in both of those, not 2.
Our third method has to do with using our law of logarithms. And sometimes we can expand or condense using those laws of logarithms in a way that's going to help us solve the problem. For example, in here, I have log base 3 of x plus 1 minus log base 3 of x minus 3 equals 2. I have my variables in two places. So not only do I want to get my variables out of the log, I need to get my variables together in one log so that I can get them out of the log using method E1 or L1 or L2. So I'm going to use my law of logarithms to condense this. Remember, I'm going to take that subtraction to division, and I'm going to write this as the log base 3 of x plus 1 over x minus 3 is equal to 2. And now I have the kind of equation that works great to use either method L1 or L2 on. I'm going to think about maybe using method L1 on this and convert this to exponential form. And I might write this, if I convert it, as 3 to the second power equals x plus 1 over x minus 3, which is 9 equals x plus 1 over x minus 3. And now I have a rational equation. Remember, we solve rational equations by multiplying by the common denominator. So what I'm going to do now to solve this rational equation is multiply this by x minus 3 on both sides. I will get 9x minus 3 is equal to x plus 1. We'll have to do a little bit more work to clean up this linear equation, but this is something that we should be familiar and comfortable with. Let's see, 9x minus 27 over here is equal to x plus 1. And now I can get those x's together, and I'm going to subtract an x and say that 8x minus 27 equals 1. I can add 27 to both sides and get that x equals 28 when I add that 27 on both sides, and then we'll divide by 8. And when this simplifies out, I think we're going to get x equals 7 over 2. We'll have to find some common factors. There's a 4 in both of those. If I divide the numerator and the denominator by 4, I'll get 7 over 2. So that is my answer. But what I want to highlight, this seems like a lot of work, but really this was method L1. Combining those was method L3. This was the method L3. Over here, I did either L1 or L2. I did L1, but you could do either. And all this stuff over here, that's solving rational equations. That's 1710. This is stuff that you've seen before. It just ended up being an equation that took a little bit more work to solve. But really, this is all the new pre-calc stuff here. Okay, and the last method that we'll talk about, L4, is about equating arguments of equal logs. So if we have log base, in this case, log base 3 of something equal to log base 3 of something, it has to be that those insides are equal to each other because the bases are the same. So we can just straight up say that 2x equals 7x minus 1. And now I have a really lovely linear equation that we can solve. I can add 1 to both sides of the equation and subtract 2x, and I'm going to get 1 equals 5x. And then I'll get that x equals a fifth when I divide both sides by 5. Okay. So those are our 4 methods. Really, I'll say that L1 and L2 do the same thing. You can pick your favorite. Let's compare L3 and L4 when they would be useful. What's interesting about L3 and L4 is that unlike our previous 2 methods, both of these have places where maybe the log occurs in 2 different places. I have log base 3 of something and log base 3 of something on 2 sides of the equation. In L3, I have a log, and a number. And in L4, I just have a log and a log. So if you have an equation that's all logs equal to each other, or plus or minus or things, you might want to equate exponents or try to combine into things and then equate exponents. But if you have logs and numbers together, you're going to have to use maybe an L3 in combination with another method. Once you've combined it into one log, then you can go from there. Okay, so that's an overview of our 4 methods, and we will practice using them in the next video.